So today we will be talking about something that how we can get started with the data preprocessing, how to use Numpy and Pandas for data munging and data wrangling. And before that, let me just have your quick reaction that how many of you are comfortable with this Python. You already know Python and you have worked with this. And okay.
Sir.
Okay, so what I can see, just only a couple of reactions for this. So how many of you are having the first, kind of tryst with this data science in Python? How many of you are using it first time? Okay, so there are many people who are into this field first time. Okay, so let me just get you started from some of the basics, and then we'll be switching to some of the things related to how to use pandas and numpy. Basically, what is this field of data science? So data science is something because in modern times, data is diamond. Even it is more precious than gold. And this is everything that you need to keep your businesses running. So this is the new oil for the businesses. And if you have data, then you can decide, you can take strategic decisions based on that. You can analyze the data, and you can devise some of the business strategies based on that particular data. So data is very, very important, and there are different varieties of the data. We have text, we have images, we have video streams, we have financial data, and we would like to analyze that, and we would like to infer some of the interesting things, some of the interesting patterns from that. And machine learning and deep learning can help us doing that stuff. And there are various steps as far as the data analytics is considered. First, we need to have the step of creation of the data. Then we need to have some pre-processing and some sort of cleansing of the data. Then we should create our machine learning models for doing various stuff, like whether we want to do supervised learning, we want to do semi-supervised learning, we want to go with unsupervised learning. So we can extract patterns, we can find the useful insights from the data, and that is quite interesting. So deep learning is emerging as one of the uh, uh, one of the fields where you can solve various problems that humans find it difficult to. So various pattern recognition problems can be solved with this concept of machine learning and deep learning. Okay, so I'm just sharing my screen. Okay, are you able to see my screen?
Yes, sir.
Yes, we
All
can.
right.
Yes, sir.
So let's get started something hands-on, because I want this session to be hands-on, and we'll be getting started with some of the basics. If you wish, and I will recommend that you also repeat those steps with me. And for that, you do not need to have any software or pre-configuration on your system. If you're just having a laptop and you have access to a browser, then you can repeat those steps. And for today's session, I'll be using Google Colab. I think you have some basic understanding of how to use Colab in the last session that was conducted by Kapil. So
Yes,
all
sir.
of you know that how to use Google Colab. and what Colab is?
Yes. Yes. Yes.
Okay. So what you can do, you just type in the Google, just Colab. Otherwise, you can just type this, URL, which is colab.research.google.com. Okay. So it'll open the Google Colab. You should be logged into your Gmail account. That's the only requirement. You should have a Gmail ID. And lots of noise coming in. So is there any specific reason for that? So I would request that all of you please mute yourself.
All
If
the
you want to,
participants, please mute yourself.
if you have any question to ask, then only you please unmute. So this is the interface of the Google Colab, and there are various tutorials available that how to get started with Google Colab, what it can do, and it is connected with your Drive. So I'm using the pro version of this Google Colab, which comes with some of the advanced features and some of the advanced computational power. So this is my Drive, and okay, I just need to click here, and these are the different folders that I've created. This is the data which is available in my Drive, and this is one folder that I've created. So inside this particular folder, what you can do, you can create a Google Colab file, which is basically the interactive Python notebook. And at the back end of this Google Colab, there is Jupyter notebooks running. So it is based on that. And if you're using Google Colab first time, then you need to add this to your Drive. So this is just a kind of application which is provided by Google. So you can add it if you're using it very first time. And for that, what you can do, you can just go right click and just click on the more. And here you will get Google Collaboratory option. If you do not get it, then just click here on the connect more apps. And then, this this kind of marketplace is opened where you can look for various applications. And if you want to install Google Colab, so just type here Collaboratory, and here it is already installed. If you're using it first time, then you will have to just click here and it will automatically integrate with your Gmail account. Once it is integrated, what you can do, you can create Colab files. So for that, just right click and go to more and just select from here Google Colab. Okay. Right. So this one file will be opened here, and it is untitled. If you want to, just give it a title. So it comes with extension .ipynb. Just change it to, anything hello.ipynb. And just save it. And this ipynb extension is interactive Python notebook, which is the extension, the default extension of Jupyter notebooks. So in the backend, this Google Colab is using a Jupyter notebook. Now, so here you get a cell where you can write any code, and there are two types of cells available. Either you can have text cell or you can have code cell. So it also comes a very good markup language, which is called as Markdown. And if you want to include some documentation in your code, then you can do that. And there are various markup tags associated with that, and you can have a kind of full-fledged tutorial interactive notebooks. And so here it comes with all the most of the functionality that a data scientist requires. So it comes with various popular libraries pre-installed. If you want to do some numerical computation, then it has NumPy. It has SciPy. If you want to do some machine learning stuff, then it comes with sklearn. If you want to implement some deep learning stuff, then it has pre-installed Keras and TensorFlow. You can train your deep learning models. And even if you need to install some of the advanced packages which are not available here, then you can also do that. So it supports the installation with the pip, which is the package manager in the Python. So in next 2-3 minutes, I'll just introduce you that how Python is different from other programming languages and how it is most suitable for data analytics. So as we know that Python is a multi-paradigm programming language, and there are three popular paradigms of programming languages. We have procedural languages like C. We have object-oriented languages like C++, Java, and we have the functional programming languages like Scala and Swift. So there are three paradigms of programming languages. There are the functional programming paradigm, the procedural paradigm, and the object-oriented. And Python is a multi-paradigm programming language. It means that it supports all the features. So it has the capability of the procedural languages, because you can define functions in Python and you can divide your code into smaller units in the form of various functions. It has the capability of defining objects and classes, and some of the basic concepts of object orientation can be implemented, including inheritance. And so it is somewhat object oriented, and it is functional programming language. So what is functional programming language? That it has Lambda expressions, and it does not suffer from the problem of side effects. So the Python does not have the concept of increment and decrement operators, because they suffer from the problem of side effects. Because if you are doing in C, if you're writing a program like this, int C equals to 10, and then you are writing an expression x equals to C plus plus, and then plus, and then minus C, then again you are writing C plus plus. So it becomes sometimes platform independent and sometimes the compiler dependent, and you cannot exactly predict that what its output is going to be. So that is the problem of procedural and the programming languages which do not support this functional paradigm, where it is very strict about this side effects, and you have explicit instruction on how an expression is going to evaluate. So Python overcomes that problem by supporting the functional features, and for that thing it doesn't have these increment and decrement unary operators, because they cause problems. So Python is a multi-paradigm programming language, and there are certain things that Python is different from other programming languages. It has two things in mind. It was created by an individual, Guido van Rossum. So when he created this language, so he had the ideology of making it simple and readable. So everything is decided, the syntax is decided with the indentation, and indentation plays a very vital role, and it also enforces the readability on the language. Another thing is that Python is very you may say that it is a dynamically typed language. So if you want to declare some of the variables, you can do that, and you do not have to specify the data types of these variables. So x, y, and z, the data types of these variables will be decided with their R values. So here the value of x is integer, and the type of value here for y is string, and the type of z or the JAD is float here in this case. So yeah, there are data types in Python, and but the Python is dynamically typed. So the data type of a variable is decided with the R value that it is having, and that can be changed at the runtime. And if you just want to print that what data types they're having, then there is a function type, and that will give you the data types of these variables. So type of X, type of Y, and type of Z, you can print it. And if you want to execute, then for execution, so this is the play button, and you just press it and you'll get some output. And another thing is that when you are writing your program, then it is very simplified. If you just declare a variable, so it is the first time it is initializing a virtual machine on the cloud, and then it is allocating a virtual machine. So from here you can see that how much of the RAM and disk space you are using. So you can use up to 15 GB of disk space, which is by default provided by Google Drive, and you can even change the runtime from here. You can select the GPU and TPU if you want. So this environment is very powerful, and on the top of that, it is supporting this Python, which is very easy to learn, and which is multi-paradigm programming language, and it is very suitable for data analytics. So here you can see that the types of X and Z are float and int. So there are built-in data type classes. Yes, they exist, and but you do not have to enforce it on the variables at the time of creation, and the syntax is very easy. So if you just print the hello world program in Python, so it is just one line of the code. So you can just print hello and world. So and then it will print the hello world. I think it is the it is the smallest piece of code to print hello world as we compared from the traditional most popular programming languages. Because if you are using C, then you need to define main, you may include some header files, and then you need to compile it, and then you need to execute it. If it is Java, then it will take few more lines, public static void main, and then you need to compile it. There is naming convention, then you need to execute it, the bytecode. If it is C++, then it will take lot many lines, but here it is very simple. You do not have to define any main function. You just write the code and it gets executed. So another characteristic of Python, that it is interpreted, it is not compiled. So whatever code you write, that converts to the to the executable code one line at a time, and then it gets executed. So definitely there is syntax checking, that if there is some syntax error, then it will check. The interpreter will throw some errors as far as the syntax checking is done, but it is very easy. It is interpreted, and it is dynamically typed language. It is made for readability, and it is made for data analytics. So why it is made for data analytics? Why do we use Python for data analytics? So let's take an example. If you want to perform the 12 and you want to raise it to power 12, so that is something a big number. And if you just want to print the value of C, then you can print it with this. So this is some big number that I think you may store some number, but you'll have to consider a big data type. You'll have to pick and choose that in what data type we can store it in C, in C++, and Java, because there is a range for every data type. But if it is even bigger value, then in Java and Python and C++, you'll have to think that how it can be saved. Because if you calculate the factorial of a very large value in C, then that cannot be done with simply primitive data types. For that we need to create some trick. We make an array and we keep on storing that. So here you can see that how big this value is, and still you are able to save it in a variable without bothering that how it is going to save, how many memory will it take. And even if it is large enough, then you can calculate its value, and the data that you are getting is maybe 1,000 digits long, and that is the capability of Python that you can use it for. So it can handle a very, very large data. It comes with a very rich and powerful API, which stands for Application Programming Interfaces. It comes with thousands of packages, and there are thousands of modules, functions defined in them, and then you think of any task and you can do it in Python. So whether it is data analytics, there are various libraries for doing data analytics kind of jobs. You can have various powerful built-in data structures available with Python. We'll be talking about some of them. You have libraries, like if you want to work with 1D or multi-dimensional data, then we have Numpy. If you want to do some of the scientific calculation, we have SciPy. If you want to do some statistical analysis on the data, then we have stat models. If you want to do data analytics on various documents, you want to process the Excel sheets, you want to process the text documents, you want to process CSV files, then we have this Pandas library, which is very, very powerful, and it comes with many useful functions. So, and if you want to do web scraping, then we have libraries for doing that. Scrapy Beautiful Soup can make your tasks of web scraping very, very easier. If you want to do networking sort of thing, if you want to develop network applications, then we have libraries for networking. If you want to do text analytics, then there are various libraries for doing text analytics. We have NLTK, we have Jansim, and you can create various types of text processing models out of that. If you want to go with deep learning, which is a buzzword today, and in deep learning, based on the type of problem that you want to solve, you have tools and the all the paraphernalia that you require for that. You have support for Keras, that is a high level wrapper written in Python, so that can support at the back end the TensorFlow. It can support the Theano, it can support the Microsoft CNTK, it can support various other libraries. So the Python, the realm of the Python is very, very large. You can do anything, even you can do web application sort of thing. So it comes with the various frameworks for that, Django and the Flask, so you can do that. So it means depending on the type of application, depending on the type of problem that you want to solve, Python can provide you all the tools and packages and libraries for doing that. Okay. So this is some of the basic, and there are many special things as far as the Python is considered, and so there are many unique things in Python that you can do as far as the data analytics is considered. So Python comes with 6-7 built-in kind of data types or data structures. So I'll be just talking briefly about these data types. So we have numbers. There are 3 types of numbers. We have strings. We have is Boolean data types, true and false. We have lists. We have tuples. We have dictionaries. We have sets, and we have rodded data types as bytes. So these are some of the built-in, or may call as the primitive, not the data types, because they are really complex data structures available in Python. If we talk about numbers, there are 3 types of numbers. We have int, we have float, and we have complex as the built-in data type. If we talk about strings, we do not have character data type. Even if you are writing, single character, it will be a string. So we have strings. For Boolean, we have true and false values. We can have Boolean data types. And lists. Lists are the heterogeneous mutable data types, and we can create a list like this. So L equals to, and you can have heterogeneous values inside this. You can have multi-dimensional lists. And okay, we have tuples. Tuples are kind of immutable. You cannot change them, but you can store the data. And the tuples are just the comma separated values. You can create a tuple like this. And they are very fast for data processing. They just act like cursors. And we have dictionaries. So dictionaries are very powerful. They are just like the jagged arrays available in many programming languages. You can have named index, you can have integer index in the dictionaries, and they are the key value pairs. So we have keys and the corresponding values in the dictionary. So a dictionary is defined like this, and then we have the key value pairs. And then you can have various values associated with them. We have sets. Sets are also defined like this, but they are just the numbers or some, some strings. You can keep any type of data inside them, but you cannot have repetition of the values. And then we have bytes, we have byte arrays and other data types. So this is something which is the part of Python, and there are various built-in functions available with them. And we need to have the basic introduction of these data types, but we'll be moving towards how to use pandas and numpy. But understanding of these data types is very, very important. And if you want to learn data analytics, then first you need to have the basic idea that how we can create and use these data types. So there are, if you talk about in totality, there are hundreds of functions which are available with these data types, and those functions make your life very, very easy as far as the data analytics is considered. So they have very, some of the very, very interesting features. Like if you just talk about strings. So a string is just a sequence of characters. So you can define strings in two ways. Either you can have single quotations for a string, or you can have double quotes for a string. And what is special about strings? The indexing and the slicing is very, very powerful in strings. So this is a string. If you want to print it, you can use print function. Or if you write the name of some variable at the last, then that becomes the output of your current cell. So here let's print the value of s. It is hello world. If you just want to get the first character out of this string, then this is called indexing. And interestingly, it also supports the negative indexing. So if you want to display the first letter, then it will display with -0. If you want to get the last character, then it will display with -1. So -1 is the last character in your, or the last element in your string. And if you print it, you'll get the value D. So the indexing is from starting, or it can be from ending. And what is another thing? That is slicing. The slicing is very, very powerful operation, and that can be applied with data types. And these slicing and indexing are extensively used. Even when we'll be using our machine learning models, where we have certain features as the part of X, and we have certain class levels, then also we need to divide the data into two parts. So their indexing plays a very vital role. And it is very, very powerful feature of this Python. And the slicing can be done like this. So yeah, if you want to get a part of the string, and that is from 0 to 4, 0, 1, 2, 3. So here you are getting this value, and it is starting from 0 and it is going up to 1 less than the last index. So the value that you're providing here is excluded, and it will print the values at the index 0, 1, 2, and 3. So this is the slicing operation, and it has three parts. So the first one is the starting index. The second one is the last index, obviously one less than the last index, and the third one is the step. If you want to get all the values from suppose 0 to 6, and that too at a difference of 2, means you just want to print the alternate characters, then it will print like this. So it will print the 0, will skip the 1, then print 2, will skip the 3, then 4, and then print it like that. So this is quite interesting, the slicing and the indexing part of uh, which you can perform with the strings or other types of even the arrays and the lists. So that is very, very powerful, and that is used. So if you remove this, then it will consider, it will take the entire array, and it will do that. So what I recommend that you practice all of these data types, and there are various built-in functions on those data types. Like if I just want to create a list, and so this is a list, and if I just want to see the type of this list, then I can see that what type of list is is it. So it is a list, which is a built-in data type, and you can perform various operations on this list. And if you get here L dot, then you get these functions on the list that you can call. If you want to append, then you can append a list or a number to this, and the new value has been appended to this. So just practice them. And there are various functions on other data types as well. Suppose if there is a set, and you want to create a set, and you want to create another set, then you can perform various operations on that. And they have various useful cases for them, because these fundamental concepts are used because when we try to learn some of the advanced libraries, then in between these things are there to solve various problems. And the set cannot have the repetition of the values. Suppose if you write another value here, 45 and 45, and if you print the value of s, then this repetition will be discarded, and it will just take only only one time this value. So it helps a lot. It is extensively used in text processing. Suppose you're working on a text and you just want to get that how many unique words are there in the text. So you will load the file. You would split the words. There is a split function that we can call on a string, and the separator that you are using is space. So it will consider the text into it will split that out, the text. And if you store that particular text in a set, so what will it give you? It will give you the unique words in the text, and that you can use for further processing of the text. So these data types are very, very useful, and they are the foundation of any task that we may like to perform. So if you want to see that what are the different functions, then just create a variable of that type and just place here dot, and then you can see that what are the different functions that I can call on this type of variable. So this is very, very intelligent, very, very prudent. and it will suggest you some of the methods. Like suppose if you want to call union method, so there is union. If you want to call update method, if you want to add some element to the set, then you can do that, and it will take lots of time, but that is not the objective for this session. So what we are going to do, we are going to discuss about NumPy and Pandas. So NumPy is something, so here you can see that the built-in data types that we have used, we have not discussed anywhere the array. So though this list can be used as an array, but NumPy data type is there, which provides us the functionality of multi-dimensional arrays. So if you uh, want to process our data in the form of arrays and we want to store it, then it comes with a very, very powerful data type, and that is ND array. So multi-dimensional arrays are there. So ranging from 0 dimensional to any dimension of the array you can have, and you can have heterogeneous dimensions, like the first row is having just 3 elements, second row is having 5 elements, and the fifth row is having 6 elements. So you can have that sort of data. You can have any type of dimensions, and NumPy is a built-in package available. So how we can import any package. So for that, we just need to use import and NumPy, and we can do the aliasing for this package. So generally this NumPy is, 5-letter name, and we would be repeatedly using it. So instead of using this, we can just do a aliasing for this. So wherever we'll write NP, it will automatically refer to the NumPy. Okay, so what you can do, you can create, uh, the different types of arrays with this NumPy np dot array, and just print the type of this array. So this is numpy.nd array, which is the built-in data type of this NumPy package, and you can have multi-dimensional arrays as well, and you can refer its values, and it is extensively used for processing. So the same thing can be do with list. So whatever we are providing here is a list, and then it is converting that into n-dimensional array. So how the list is different from the NumPy array? So the NumPy arrays are comparatively faster. So they are about 1.25%, means 125% faster, or 1.25 times faster as compared to the primitive lists, and they make the data processing very efficient, and there are various functions available as part of the NumPy that can do lots of things. They can have multi broadcasting operations. They can easily, you can merge two arrays together, and you can perform various statistical functions on that. So the NumPy arrays are very, very useful, and mostly libraries which are used for machine learning or deep learning, they accept the data to be in NumPy arrays. So NumPy arrays work in the background of most of the libraries like sklearn and Keras and TensorFlow. Like Keras accepts only 3 types of data for machine learning. For learning, for reading the data, either you can have in the form of NumPy arrays, or you can have in the form of built-in arrays, or you can have in the form of generators. So if the data is of type image, then it will be like image generator. If it is of type text, then it will be of type text generator. Okay. Yes, is there any question to ask? All right. So there are different functions on that you can call here as well. Like if you want to get the max of this array, then you can easily get it. So you do not have to write the entire program. So we cannot do something, very interesting. So there are various operations, primitive things that you can do. And at the back end of Pandas, so there is NumPy and SciPy package that runs, and we can do lot many interesting things with the help of Pandas. So we'll be using NumPy as well there. But what I'm doing, I'm just taking one example from a data set, and then we'll be performing some of the operations using Pandas. So I think that will help you a lot. But otherwise, when you want to seriously learn this data science, then invest a fair amount of time in basics, because these are the basics which underlie anything. Because if you do not understand the basics, then it will create lots of problems, even if you are writing some complex machine learning or deep learning. So code is available, you'll find code everywhere. That is not the big deal. There are lots of resources, but understanding that code and developing skills for doing something out of box is the requirement. Or creating something that can solve your own problem is something which is expected. And for that, understanding the basics will help you a lot. So let's try to use this NumPy and these pandas on some real stuff. And for that, I'll be using a very simple data set today. And this data set is available, that is titanic.csv. So that is a very popular data set, and you can download it from Kaggle. So it is available on the Kaggle. One competition was there, some initial competition was there. And Titanic data set CSV. Okay, so this is the link on the Kaggle. You can find it on other places as well. Look it for UCI machine learning repository. So this data set is available, and it was a competition. So you can apply the classification. You can train your classification on this, and it can be used for the binary classification problem based on certain characteristics of the passengers, some of the attributes of the passengers. You can predict whether the passenger would have survived or not. So this is the data set, and so this is task.csv is the file that you need to download, and there is train.csv. So this is this particular data set is being used here for a classification, for a binary classification problem, and that is a legacy data set that you can use. And if you want to work on other types of data sets, so you can find plenty of the data sets. For getting started with UCI dataset repository is a good starting point. So this is University of California, Irvine, and there are different data sets available here. I think hundreds of data sets are available, and based on what type of problem you want to explore, you can download the data set and you can work. So for classification, there are different data sets, 417. For regression, there are 129. For clustering, there are 112 data sets. And you can also have kind of categorization, whether you want to work with categorical values, with numerical values, with mixed values, what type of analytics you want to do, multivariate, univariate, sequential, or what, in which area you want to explore. So this is a very good repository of the kind of traditional or most popular data sets. So the size of the data set is moderate, that you can easily work with. And so these are very old data set. The year is also given. If you want to work with some latest problems, so the Kaggle is also the another very good source where you can find some interesting problems. And you can even take part in various competitions which are happening on the Kaggle. So there are, $1,000, $5,000, even $1 lakh are there. And if you can create some models, if you can solve some of the unsolved problems, then so this is something which is when you reach at a at a level from level 0 to level 1 or level 2, then you can explore these things. And for the time being, what we are doing, we are just downloading this data set, which is this one, Titanic. And okay, so in total there are 700-800 rows, and in training set there are just 400 or 500 values. And why it is important? Because it has various things that we need to do for as far as data wrangling or munging is considered. So we have some missing values. We have some, the values which have very low representation, and we would like to get rid of them. And we'll be filling some of the values with, some of the common features and something like that. So this is a very, good starting point for applying the skills of pandas. And okay, what I'll do here, I'll be reading the data set from my this drive, and the drive is just GG underscore Atal underscore CMS. So this is the folder inside my drive. Now, in order to be able to read the value from this drive, I need to mount it, because you are working on some virtual machine, and this Colab is something which is a kind of external tool, and your drive is something which is private to you. So Google expects you to provide accessibility to that. And for that you need to mount it. And so I'll be writing here just 2 lines from google.colab import drive. Okay, and I need to then mount it, drive.mount. So your access starts from my drive. So this is your drive and this is my drive. So this is your data. But before that drive also, there are two folders that you cannot directly access, but that acts as a root. So there is a content folder, and there is drive folder. Sometimes it is also used as G drive. So okay, so you can use it. So this is the drive folder, and then your my drive starts. So this is just a kind of root folder as used in Linux, and then your actual file system starts. So once it is done, then you just need to execute this particular code. And what it is asking, it is asking for some authorization code to enter, because it is making access to your drive, and for that you need to click here, and you need to explicitly be logged in to this. You need to allow it to access your local drive. You need to copy this particular code and then just place it here. And once the this validation is done, then your this Colab file can access your drive. So you are mounted at this particular point. Okay, so now it can access your drive, and if you just want to see that currently in which folder or in which directory are you, so there is a very interesting package with Python, that is OS. So you can import OS, and you can see that what is your current working directory. So os.get cwd, which is current working directory, and you can get an idea that where you are currently which is the current working directory on which this particular collab is mounted to. So this is the root, which is the content. You can even change it. So there is chdir function, and so there are various low-level functions at the operating system. If you want to create a folder, then you can create. If you want to, change the working directory, then you can change that. Okay, so we have mounted it. What is the next thing that we would like to do? We would like to read our data. So for reading our data, what I'll do, I need to import this pandas library, because I'll be using most of the functions of pandas library. So what is interesting with Python, that you have multiple ways from multiple libraries to do the same thing. So there are multiple routes of doing same thing. There are certain functions in NumPy, and there are similar functions in pandas. There are similar functions in matplotlib. The same functions exist in Seaborn or other libraries. So you can use any one of them, and there are lots of options available. So it is not like that there is only one way of doing the things. Like if you want to read the files, so you can use pandas. You can even use some of the functions from NumPy as well to do the same thing. So I'm importing pandas as PD. So this panda library will be imported.
Sorry, I have a question.
Yes,
Can you please share the CSV file?
Okay, CSV file. Let me just check it whether the chat is enabled here or not.
No, chat is not enabled. I think you have to send an email to coordinator.
Okay, so what you can do, you can download it from this Kaggle.
Yeah, but in Kaggle there are two data sets. I think train and test.
Train and
If you
test.
have
So
the same
just
one,
download train.csv.
Okay. I just want to make sure that when we practice, we get the same kind of results, so that we
Okay,
can.
no issue. I am just sharing my folder on the WhatsApp group. So I'm sharing this entire, this particular folder currently where I'm working on.
Okay, thank you very much.
Okay, so this is the link, and then you'll get access to all the resources. So maybe in the next sessions, when we'll be talking about machine learning, deep learning, and all the things you'll get from here. So only for my sessions. Okay. Is it all right? Are you able to access the folder?
Yes, I'm able to access. Thank you.
Okay. So I've imported this pandas library, and what I need to do, I just need to load this particular data set. So it is just one part of the data set that is used for training on the Kaggle. And for loading the data set, what I'm doing, I'm calling the function of pandas, which is read underscore CSV. And here I need to provide the complete path. So my complete path is that this is the root, the content and drive. And inside this particular drive, there is a folder my drive. And then there is a folder given as GGU Atal and then CMS, and inside this folder there is a file titanic.csv. So there are various functions available with this, this pandas. If you want to read CSV, then there is read underscore CSV. If you want to read a data from the JSON file, then there is read underscore JSON. If you want to read from the Excel, then there is read underscore Excel. So, and even if the data is available in various other formats, like HDF5, then there are different functions for doing data stuff. So once you do it, let me just check it whether everything is okay or not. So everything went well. Otherwise, it would have given some error if it was not able to access some of the files, or some typo errors would have been there. Then it would have shown you those errors. So now this particular data, the entire file. So titanic.csv, this entire file is available with you, and this is the file that I downloaded it offline. So I'm just showing you that what exists in this particular file. Okay, so let me just open it in some text editor. All right, so this is the data which is in the form of comma separated values. The first row is the names of the columns. So there is passenger ID. This is one column: passenger class, name, sex, age, number of siblings and spouses. So this is one attribute. Number of parents and children. So this is one filter. The ticket, which is containing the ticket number, fare, cabin, whether the person was having cabin or not, and this is the location where the person just boarded the Titanic ship. So these are the attributes. How many attributes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 attributes, and there are 418 rows. So there are 418 records, because the first one is the names of the columns. So this is not the complete data set. It is just the train part taken from the data set that was divided into two parts, train and test. And since we are not training any model as of now, we are just trying to see this data set and trying to pre-process it so that it can be used for machine learning or some other analytics tasks. So here you can see that there are various missing values in this data set. Like this is the missing value, this is the missing value, and there are some of the columns that may not be of any use to you when you'd be performing some analytics or machine learning kind of task. Okay, so this is just the data set, the overview of the data set. I have read this data set, and if I just want to display that what is there in the data set, then I just need to write df. And this pandas supports two types of data structures, and with those data structures it can do all the magic. So either the data can be in the form of one-dimensional array, so there is series, or it can be a 2D array, so that is in the form of table, so that is a data frame. So the data frames are extensively used for reading the entire files and then later on doing some sort of processing. So it is displaying everything, but there is a restriction on the data that can be displayed. So it displays the starting few rows, and then it is displaying the rest of the few rows, and it is showing you the dimension of this data. There is 418 rows and 11 columns. So actually there are 419 columns, but it is very very prudent, and it takes the first row as the as the as the names of the columns, and it considers rest of the data uh, as the value. And so df, so there are various functions that you can call on this. Just you need to df and dot, so you can these all functions are valid to be called on this. So some of the functions are very very generic, and if you want to just see the few rows of this data, then there is head function. Like if you just want to see the first 5 rows, by default it will show you the 20 rows, 20 initial rows of the data. And okay, so it's the indexing, it is starting from 0, and then this is passenger ID and passenger class and the entire data. So yeah, you can do it. And you can further have the slicing and indexing sort of operation. So there are different built-in functions available. There is lock function, ilock function. You can have indexing of the data. In the same way, if you just want to see the last few rows, then there is a function df.tail, and it will display the last 5 values. And here you can see that what is the type of this T. So it is a data frame because it is a 2-dimensional array. And if you just want to get one column from this, like if you just want to get the age, so you can do that, but the columns are just the 1D arrays, and it will automatically sense it that this is a series. So there are two primitive or kind of built-in data types available with pandas: the series and the data frames. Data frames are a kind of 2D tables, and the series are just in the form of just 1D arrays. Or if you want to see it, that what is there inside this, so T dot array, and you are just talking about the 5 rows. So NaN, it means it is something which is missing or which is not available, and these values are there which are available. Okay, so you can do this kind of stuff with by reading this particular file, and that is turning to be a data frame. And data frame is very, very powerful, and you can perform various operations with the help of this data frame. Okay, so what next? We are just going to check that which columns are having some of the missing values, and what is the count of those missing values. So that is quite interesting, and that is something that we need to do as a part of data munging or data wrangling, where this pandas can help us. So okay, so before that, later on we'll apply it on all the columns, but because for that we need to define a lambda expression and call a built-in function apply for that. But before that, if you want to just see whether a given column is having some of the null values or missing values, and we just want to see something about age or cabin, that how many people are having cabin, and how many people are not having cabin. So that can be done simply. We are just calling this sum function, and then we are calling this df, which is our data frame, and from df we are extracting this column cabin, and then there is a function is null. Okay, so what it will do, it will just give you the number of values which are null in this particular column called as cabin. Okay, so out of 418, there are 327 rows which are having a null value for this particular variable column. So this particular column may not serve a very well purpose, because only just very few rows are having values assigned to this particular column cabin, and we can later on drop it. So we do not want this cabin to be a part of our data set. So what we are going to do, we are just dropping this particular column cabin, and for that df.drop is the function. What we want to drop, cabin. You can even drop multiple columns together, and you just need to specify that when you are performing drop, whether it has to be at the column level or at the row level. So these are some of the the doc string that is coming up for this drop, and there is an attribute called as axis. So by default it is 0. So 0 means it will work at the row level, but here you want to work at the column level. So here the axis need to be specified as 1, and it will drop that particular column. And once this drop operation is done, then you need to update the data frame. So it will perform this drop operation, and then it will assign the new data frame to the previous one. So this is very simple. It has to be done only once. If you execute it one more time, so it will give you an error. Why? Because this cabin has already been dropped, and you can just drop it only one time. Otherwise, next time it will not be able to find this column. So now you can see that what is your new data set. So df dot add, and you want to look just starting 4 rows, and this is the data set. So instead of having 11 columns, it is just having 10 columns, and the column that was cabin has been deleted from here. And why do we deleted it? Because there were 327 missing values, and so with those many of missing values, it was not serving any purpose for that, and so we dropped it. And so let's have a look at another column, and that is the ticket. Like, what type of data does it have? df, okay, ticket, okay, and let's have the values, the starting values of 0 to 5. Okay, so what here we are doing, the first part is accessing the column ticket, and the second part is giving you a slice of that particular ticket column. So it will just give you starting 5 rows, starting from 0 and ending till 5. So this is something that the ticket is having. It is just the ticket number, and if you want to print the entire column, then you can do it. And here in some of the tickets, there is a mix of this text, and then these are the numbers So again, this is the text and this is the number. So our ultimate objective with this data set, for what it is used, is to classify or to predict whether a person is going to survive or going to sink in the ocean. So that is the ultimate objective, and the ticket may not serve any useful information in that regard. So we can also drop this particular column ticket. And if you want to drop multiple columns, then what we can do, we can just do it by passing those columns here in the form of a list. But this cabin has already been dropped, so it will again give you an error. But if you reload this data set, then you will have a fresh data set, and now you can simultaneously perform these two operations. So this is something that we can give us errors, like if we have deleted something already and we are executing the same code, then we may have some errors. And what we do, suppose we have written multiple lines here, so the error was in second line and this particular row executed successfully, then we will not be able to, even if we have corrected this error on this particular line and we are again deleting the same thing, then we will not be able to print it. So suppose if you want to print this value of df again and you are executing it, so you are getting an error. You will say that what is the syntax, what is the wrong in the syntax. At first time it executed successfully, but this time it is not executing. So what you need to do, you need to keep it in the separate cell and then you need to do it. So there are many operations that can just work once, and deletion is one of them. And if you want to print it, then you need to do it in a separate row. So okay, so we have even deleted, okay, df and ticket.
Can we also delete name and passenger ID? I think they don't have any effect. Right?
Yes, we can do, but what we'll be doing some interesting stuff with this name. We'll be extracting surname, the salutation from the name, because name is complex thing which is having the family name or the surname and then salutation and then the first name. So out of that string, we'll be just extracting the salutation separately and we'll be creating a separate column for that. Otherwise, you can delete if you find that some of the columns are irrelevant.
Sir, instead of
Yes.
deleting,
Okay.
sir.
Yes, please.
Yes, sorry, I have the one doubts. So instead of deleting our own, so we have to apply the some optimization algorithm. Can you able to apply it and then remove the columns as an unwanted column? Is this possible?
Yes, for that you need some sort of heuristic and
Yes,
some sort of
PS1,
clue.
for example, genetic algorithms. So getting the optimized column instead of deleting our own.
Yes, you can definitely apply that from where you are getting that heuristic or that clue or that idea, that which are the columns that are not contributing very much for
Yes.
that. So that is something which is a part of separate exploration. But this idea is coming from somewhere, like if the column is having largely the missing values, then it may be the good idea that it may not contribute anything meaningful. Even you cannot fill those missing values with the average and something like that, because the proportion of those values is very less and it may not communicate the well information for training your model. So it is good idea to exclude that, but which are the columns that are to be excluded? So that need a separate exploration, and in that way you can do it. You can use genetic algorithm or some other heuristic
Some
ways for doing that.
optimization algorithm.
Yes. Optimization, you can do that. Okay, so
One more question. Sorry
yes,
to disturb you.
please.
And thank you for the explanation of the name column that we're going to use it in future. What about passenger ID? Are we going to keep it? Is there any use for that?
Your passenger ID is kind of unique feature, so that will be using for in the group Y. So whenever we want the number of values for any specific type, then we can use it with group Y. So this is just acting as a primary key for this data set.
Okay, thank you.
Otherwise, it does not have any meaningful role for that. But for data, for understanding our data and to see them in the different groups, so we are doing. So why we are getting this error? Because we have already deleted this ticket, and we cannot display it back. All right. So after deletion, how we can fill some of the columns with some of the values. And if we talk about age and how many missing values are there in the age, then age was also having some of the missing values. And if we just want to see this particular statistics for all the columns, that how many missing values are there in each column, so for that we can write a simple lambda expression, and that is df dot apply is the function. Apply is the built-in function of pandas that can manipulate the data based on certain logic. So what we are doing here, we are just defining a lambda expression. So lambda expressions are just like a kind of inline anonymous functions. Do you know what are the inline functions in C++? And then we are just defining this sum, and x dot is null, and this is going to be done across all the columns. So here the axis is going to be 0. Okay. So lambda, so here it is just acting as a function, and so here it will be taking the different columns, and according to that column we'll be finding out the number of null values, that how many null values are there, and the axis for that is 0. So it will be one record at a time. It will be just scanning it through and will be just finding out the sum for each column. Okay, so this is telling us something about that how many missing values are there. There were many missing values for what? For cabin. For ticket was we deleted because it was not having any meaningful purpose for that, because the person, if he is having what ticket number, it may not serve that purpose, because we are already having passenger class for that. And here you can see that age is having 86 missing values, and if you just think from the common sense that the people whether the person will survive or sink, so age may be the factor, because the child or the old age people who are having less or higher age, they may not survive. So definitely this age is going to play some vital role in training our model. So what we'll be doing, there are 86 missing values. We'll be filling the missing values with some value, and since this is a numeric attribute, so what we can do, we can just fill it with the mean, or if there are the categorical values, then we may be required to change the categorical values to some numbers, and then can find out what is the most common value, and then we can use it for filling up for the missing values. So the next thing is just use df dot age We'll be updating this column. So you can even access the columns with data frame and dot age instead of passing them in the single quotes or the double quotes. So df dot age, we want to fill this particular value, dot fill not available. So how to fill it? We'll be filling it with the the mean value. So for that we need to create the calculate the mean value of this age attribute. So the age mean is available in this variable. Okay, so I think it is filled now, and we can check it again. So here age is not having now any missing value. So all the values that we used have been filled with, the mean of the value. Okay, now what we can do, we'll see some of the text, processing. If you just look at dot name. So the name has been placed.
Sir, I have a question, please.
Yes. Yes, please ask.
Hello.
Ah,
Tell me more about access.
access.
Yes. Sometime pass 0, sometime pass 1.
Okay, access. So what is this access doing? By default, it is 0. And when we talk about, 0, it means the operation will be done from left to right. So it will be in the row measure order. And when we'll be, specify it as 1, it means we'll be processing our data from top to bottom. So, or it will be in the column measure order. So here what we are doing, we are processing, we have defined this Lambda function so that it can process the entire data. But what we'll be doing, we'll be checking every cell, and that will be from left to right. It means it will work for all the columns. It will check all the cells and will see that how many missing values are there for every column. And then it will display that for passenger ID, there was, as of now, there is just zero cell which is having missing value, and fare is still having one missing value, and this age was having 86 missing values that we have filled with this mean value. So axis 0 is left to right or row wise, and axis 1 is a kind of horizontal or column wise operation. Is it clear?
Yes, sir.
Okay, so now different names. So the name is having 3 parts. It is the family name or the surname. Then this is the Mr. is the salutation, and this is the first name of the person. What we want to do, we will create a separate column in our data set. So for that, we'll be combining data set, and we'll be extracting this particular this particular salutation. Okay, there is a lot more remains to be done in this data set. You can even use visualization for that. You can merge, you can create pivot table for that, and some of the part that we'll be covering in the next session of mine. So I'll be starting with 10 minutes introduction with that, and then we'll be continuing the next topic. But for the time being, we are just seeing that how to create a new column, and from the data that is extracted from the pre-existing columns. So for that, what I'll do, I'll take this particular name field and will be extracting the surname from this. will be extracting surname from this. And for that, I'm defining a function, and that is name extract. Okay, what it will do, it will accept one string and it will return. What will it return? Okay, you can just, so whatever word is there, you need to split that. And that split has to be done with comma. So what it will do, it will suppose extract this particular word, which is Spectre, and then comma, and then Mr. dot Wolf. So it will divide it into two parts. The Spectre will be one part and Mr. Wolf will be another part, and they will be indexed. So 0 index is containing this one and 1 index is containing this one. And from the index one, what we need to extract? The 0th index, and there the separator will be used as dot. So the good thing about this salutation one, or the middle term, is that it is everywhere there is dot. So mr dot, master dot, and so it is just referring the salutation. So what we did, we just split the entire name with the comma. In index 0, we are having the family name. In index 1, we are having the surname as well as the first name. So what we are interested in, we are just interested in the second part, and then again we need to split it. So we are performing again the split, and the separator that is being used for split is dot in this case. And now we are interested in the first part, which is the salutation. Is it clear? Is this particular
Yes, it's
line
clear.
clear? Okay. So this is a function, and def keyword is used for defining function. And you can call this function like name extract. And you can pass some value, like first is the surname, Singh, and then comma, dr dot Ravi. So if the name is Singh and dr and then Ravi, so it will be doing this. Okay, and all right, so let's see what is the output. So it is giving value dr after this split. And if you want to just get rid of trailing or some of the spaces, like if this space is given, then here you are seeing that there is a space coming up here, then you can call a function strip, which will just get rid of the trailing and the leading spaces. So now even if there is a space, it will just discard that. So in this way, you are able to extract the surnames, sorry, the salutations from the names. Now you need to apply this to the entire data set. So I'll just take 2 more minutes, and then I'm just finishing it. We'll continue that in the next class. Okay, so what I need to do, I need to create a separate data frame that will be just having one column, and that is df2 equals to pd dot data frame. I'm creating one data frame that will have just one column, and data frame can be created from various, like you can create a data frame from list, from numpy array, from dictionaries as well. So what I want a new data, one new column, and that is, the name of the column is salutation. Okay, and that will be in the form of so this is the name of the column, and I want to apply some operation on name, and then just dot apply is the method which will be applied on the entire column of this particular data set, which is name, and then just the name of the function that I want to call it. So here the name of the function is name extract. Okay, I need to call it, and I'll get a new column and the name of that particular column. So that will be a data frame itself. So it will be containing just the surnames of the the salutations of the persons. So here I can see df2 and just want to see the suppose head and it's starting 5. Okay, so this is Mr., Mrs., Mr. and Mrs. So it has extracted that. What I'll do, I'll add this particular column to my existing data set, and that is very easy to do. I can do that with the merge function. What I want to do, df and df2. So here I need to, it will be just a kind of join operation, and there I need to specify these two things, left index and right index. So it should be either true or false. I'm making it true. Left index equals to true. Right index is true. If you do not do it, then you will have some repetition of the data, just like the joining operations that we perform in databases. It will be just a Cartesian product of these two, df and df2, and then you need to create one merged data set out of that. Okay. And what you need to do, you need to just save that in the original data set in your, so this particular column will be added and your previous data set will be, this particular data frame will be replaced with the new one. Okay, what it is doing, just see.
Excuse me,
Okay.
sir, can you please explain the previous step once, the lambda function that you have used?
This one, okay, this one.
Data pd.data frame.
Okay, so what here we are creating, we are just creating another column. So that will be, it means we can just merge two similar things. Like if you want to merge, then those things need to be same, means their data type should be same. Like you cannot add a string and you cannot add one integer. So integer and strings you cannot add. So what is here, we are just creating a new column, but the column can be can be represented in the form of a series, but you cannot add a series and a data frame. So uske liye what you are doing, you are creating just one column, but you need to create it in the form of data frame. What you are creating a new column, and the name of the column is salutation. So it will be just having one column. This is a data frame which will be having just one column. And how you are getting that particular column, so whatever value you are reading, whatever value is there, so uspe repeatedly this particular function will be applied. So you have got some value, and that particular value is where mr.frederick. So what it will do, it will call every time this particular function. So name underscore extract is just acting a callback for this particular value, and every value that you are getting, उसमें से ये क्या कर रहा है, it is just extracting the salutation, whether it is mr, whether it is message, or it is some other salutation, doctor, and something like that. So it is applying on the entire column, and you are just converting that in the form of data frame, and that particular column is available with this df2. Now what you need to do, you need to just combine this the pre-existing data set and the df2. So for that we have this merge operation. Is it clear what is happening
Yes,
here?
thank you. Yeah, it's clear.
Okay, so what is apply? Apply is a very a function where you can call a function repeatedly. So the argument of the apply is generally a function, and whatever you keep in the left, so that particular function is applied on that value. Okay, so what next we can do, since there are some of the values which are very rare, and we can see that salutation mein how many are Mr., how many are Mrs., and how many are from the other salutations. And what we can do, that instead of keeping all the salutations, we can keep 2-3 common salutations, like Mr. is very common, Mrs. is very common, and this Dona and Master, they may not be very common. So we can keep 4-5 common salutations, and can just change the salutation type of others as just others. So that we can do, but we are already exceeding from the time, and we'll be doing few more things related to this pandas in the in my next class. If you have any questions, you may ask.
If
So
any
the next session
participant
will
is
be a
having,
continuation of this one.
Sorry, please
Will
repeat.
the next session be a continuation of this this session?
No, next session, I'll be taking my next session that is on regression and machine learning. So I think the next session will be taken by Kapil.
Kapil Tomar, sir.
Yeah. So he'll be taking your next session, and we'll be discussing about the visualization, the matplotlib and Seaborn. And then my session is either it is tomorrow or day after tomorrow. But I'll be discussing some of the things related to the pandas, and then we'll be moving to regression and this classification.
Excuse me, sir.
Yes,
Sir.
please go ahead.
Sir, just I want to know, sir, how we can know that when we should use a list, series, data frame, or NP array, sir.
Okay, so the list is a kind of primitive data type that Python provides you, and the improvement of the list is available in the NumPy arrays, and there are many functions available with NumPy array, and the number of functions on NumPy array that you can perform on NumPy array is more as compared to list. So list is extensively used even at the back end of this this pandas library. There is a use of NumPy, and NumPy is acting as the support library for this pandas. So if you want to process some you want to process some data set. Now what is the data set? Data set is in the form of some Excel sheet. So you cannot directly input Excel sheet to the list. So what you would be required, either you need to use the existing functionality related to file IO that the Python provides you, and then manually you extract those values and place that into the list. Or what you can do, you can use a very high level library where you do not have to bother about that how the Excel is going to be read, how the different columns are going to be segregated, and then there are hundreds of useful functions that you can apply. So generally when you are working on some problem, then you do not use list or other data types, but definitely they are used for doing various stuff. Like in next class, when we'll be training our machine learning models, then you cannot pass this data frame to the fit function that sklearn provides you. You cannot pass this data frame in the fit function that Keras provides you for deep learning. So what we need to do, we need to convert it into NumPy array. So there is dot values attribute that can directly convert that. So based on the various things, we may have the requirement of this conversion, and Yeah, so there is no predefined rule that when to use it or when not to use it. But as far as the speed is concerned, the NumPy arrays are more optimized as compared to the lists. And as far as the NumPy array and pandas data frames and series are concerned, so the data frames and series come up with more power as far as the access to the API is concerned. So here you just saw that how easily we could perform various munging or kind of wrangling tasks without writing any piece of code, and that's the power and beauty of this Python and its libraries.
Sir,
Yes, yes.
we have uh, executed many operations on data frame directly, and we have
Yes.
not converted it into the NumPy array. And
Yes.
NumPy array is more better, as you told me.
No, it
Told
is
us.
not better. In the back end of these libraries, means what is data frame? Data frame has been implemented with NumPy arrays only. And what NumPy arrays are using, they are using the list. But what they have done, they have just refined the basic operations. Like if there is finding out the minimum and finding out the maximum, so that is available both at the level of list as well as the NumPy. But the time that you compare, that when you do same operation on the list and when you do same operation on the NumPy array, there is improvement, there is refinement. So it is just about refinement, because at the back end of NumPy array, there is list and there are other primitive data types working. At the back end of pandas, there is NumPy, there is SciPy and other libraries working. So it is just like that. And what we are doing, we are creating more higher level things. And we'll be seeing even in our deep learning class that you do not have to write your model. And there is a concept of neural architecture search, that instead of creating model, what you can do, you just call a function and just define that how many instances of that model you want, and it will automatically create those instances and will give you the best performing model as the output. But in the background, it is using the lower level things. So Panda, it is using NumPy is using list, but there is improvement, and there is kind of convenience in using some of the advanced level functions and things.
Okay, thank you, sir.
Okay.
Uh, Thank you, sir, for having nice session. And participants, we will again resume as per the schedule. So
Thank
the
you.
session, morning session, first session is over. The session of Chandramani sir is over now.